Cubes and cube roots. So let's first talk about volume of a cube. So volume of a three-dimensional figure is the number of cubic units needed to fill the space inside the figure. So we have a giant cube shown here, and we have how many 1 centimeter cubes fill the cube on the right. So a 1 centimeter cube, 1 by 1 by 1, we're looking at how many of them would it take to fill up this entire prism. Well, it's 10 by 10, which would give us 100 cubes here on the bottom of the base, and it's stacked 10 high. So it would take 10 rows of these 10 by 10. It would be 1,000 centimeters cubed would be the volume. And cubes have the same length, width, and height. In this case, 10 by 10 by 10. So a cube have the same length, width, and height. So if we stacked up 8 cubes, we have a length of 2, a width of 2, and a height of 2. So it's 2 by 2 by 2 with our volume of 8. 2 by 2 by 2 equals 8. What about this cube? Well, our bottom is 3 by 3, or we have 9 cubes on the bottom, and then we stack it up. We have 3 sets of 9. We have 9 by 9 by 9. 9 on the first layer, 9 on the second layer, 9 on the third layer is 27. Length, width, and height are 3 times 3 times 3 is 27. So the volume of this cube is 27 cubic centimeters, or centimeters cubed. Remember, area is going to be in square units, volume will be in cubic units. So in these situations, we're looking at cubic units for volume. All right, what about this cube? We have a 9-inch by 9-inch by 9-inch cube here shown in pink, and we could use the formula of volume would be one side or one edge cubed. In this case, we have 9 cubed. 9 would be the length, the width, and the height. So 9 cubed, or 9 times 9 times 9, gives us 27. And 729 for the volume of the cube of being 9 by 9 by 9. Now, many calculators will have an option to either enter an exponent, or some of them will have an exponent of 3. In that case, you could put in 9 and either the exponent of 3 or 9, and if your calculator has a cube feature, 9 to the third power, which will give you 729 inches cubed. All right, you guys find the volume of these 3 cubes. Pause the video, come back, and we'll see how you did. All right, cube A, we have the edge, or one side of the cube, is 3. So 3 cubed is 27. The volume would be 27. Cube B, the volume is 8 centimeters cubed. And the volume of cube C is about 39.3 centimeters cubed. And we have a little rounding on that. That's why I use the little squiggly look at equal sign. That means approximately, or that we've done some rounding. As the other ones were exact, this one we had a little rounding to do to estimate the volume on cube C. So at the volume of this cube, this time we're given the volume is 216 inches cubed. How long is one edge? Well, we know that the length, width, and height, we have 3 numbers that are all the same, so we're looking for 3 numbers that are the same that are multiplied to 216. Well, this is where a cube root feature on your calculator would be really handy, because I can put in my calculator 216 and ask for it to find the cube root, and it can tell me what number that is. And in this case, it's 6. So the cube root of 216 is 6 inches. So a complex way of asking for cube root would be to give you the volume and ask you to find the edge. So don't let this question fool you as being something very difficult. It's just a way of asking for cube root. And if we check that, 6 times 6 is 36, times 6 again is 216. This is not the same as 216 divided by 3. So cube root is not divided by 3. Cube root is completely different. In this case, it'd be 6 inches would be one edge, will give us a volume of 216. All right, you guys pause the video here and find that the volume of this cube is 125 cubic feet. How long is one edge? All right, welcome back. So this is a way of asking for cube root. So I can put in my calculator, cube root 125, and I get that each edge would be 5. And that makes sense. 5 times 5 is 25, times 5 again is 125. So that if each edge is 5, then that would give me a cube root. The cube of 125 is 5. Cube root. All right, you guys try this one on your own. Pause the video here, come back and check and see how you did. So if the volume of the cube is 1,000 cubic centimeters, how long is one edge? Each edge is 10 centimeters. So there are some similarities here with and differences with a square and a cube. So the things that are the same with a square and a cube is that all the sides are congruent, and congruent meaning same in size and shape, and all the angles are 90 degrees. However, a square is 2-dimensional and a cube is 3-dimensional. And if we think about finding the area of a square, we're multiplying 2 numbers to find the area. And we think about the volume of a cube, we're multiplying the same number 3 times to find the volume of a cube. So sometimes it helps to think about this a little visually, that 2 dimensions would be square, 3 dimensions would be a cube. So the number is a perfect cube if you can take that many 1 by 1 by 1 unit cubes and form them into a cube. There's a side length of the cube you form is that number's cube root. So what does that look like visually? So let's say we take our stack of cubes. We have 8 cubes here. Can we stack that and make a single cube that has the same length, width, and height? All right, well, let's stack them together. 1, 2, 3, 4, 5, 6, 7, 8. And in this case, my cube is 2 by 2 by 2. So yes, 8 is a perfect cube. The cube root of 8 is 2. Is 5 a perfect cube? No, if I stack 5 together, I'm not going to get the same length, width, and height with 5. And if I tried in my calculator the cube root of 5, I would get a decimal. 5 is not a perfect cube. All right, you guys see if you can use the cube root function of your calculator and see if we can find the cube root of these 3 numbers. Pause the video here, come back and check, see how you did. All right, welcome back. Cube root of 27 is 3. Cube root of 216, 6. This one's a little harder than the last one. We have the cube root of 64 over 125. And what I would do with this is do each problem separately. I'd find the cube root of 64, and then I'd find the cube root of 125. So the cube root of 64 is 4. 4 times 4 is 16 times 4 is 64. And the cube root of 125 is 5, because 5 times 5 is 25, times 5 again, 125. So when you have a fraction like that, just treat it as 2 separate problems. Do the cube root of the numerator, cube root of the denominator. We can also apply cube roots and exponents of 3 to equations. So in this case, what values would work for x? What number multiplied by itself 3 times would give us 8? Well, we saw this visually a lot with cubes, that we could do 2, because 2 times 2 is 4, times 2 is 8. Now, would negative 2 work? Negative 2 times negative 2 is positive 4, but 4 times negative 2 would give me negative 8. So negative 2 does not work in this case, 2 does, so our solution is just 2. Let's look at a new one. We have the x to the 3rd power equals negative 27. All right, so I'm looking for the same number multiplied 3 times to equal negative 27. Well, how about positive 3? 3 times 3 is 9, times 3 is 27. I got the wrong number, but the sign doesn't work. Negative 3 would work, because negative 3 times negative 3 would be positive 9. Then positive 9 times negative 3 will make it negative 27. So remember, when we multiply negative numbers an even amount of times, it'll become positive. If we multiply negative numbers an odd amount of times, it will be negative. And I hope that gets you guys going with cubes and cube roots. Have a great day. OUT spells out.